Hello everyone, in this video I am going to demonstrate PWM control function for IC TL494 based 24 volts DC to 220 volts AC inverter. I am going to operate at a frequency of 65 kHz. As you can see here, this is my very raw inverter. The inverter is fed with 24 volts DC power supply and it is giving a 220 volts AC at the output. You can see here 214 volts AC is at the output. Currently I am feeding a voltage of 12.36 volts DC. You can see here this is my inverter. So now I am going to demonstrate the oscilloscope waveform first, then I will discuss the PWM control function. As you can see here, this is the output waveform. My voltage is now 12.35 volts DC and I am getting an output of 214 volts AC. So now I am going to increase the voltage. You can see the PWM action will happen and the circuit will try to control the output voltage. I am increasing the voltage. You can see the waveform will change. You can see the waveform has started changing. Just a minute. You can see the pulse width is changing. You can see further the pulse width has changed. Now my supply voltage is 17 volts DC. You can see the waveform. Now if the voltage further increases, the circuit will shut down. You can see the circuit is now shut down. The circuit is shut down at a voltage of 17.92 volts DC. I am reducing the voltage. You can see at 17.11 volts DC, the circuit is operating. You can see this is the maximum PWM done. And now at this point, my circuit voltage is 265 volts AC. You can see here, my voltage is now 265 volts AC and the supply voltage is 17 volts DC. You can see. And the PWM data, I will show again. You can see this is the PWM data. Now, if the voltage drops, suppose the voltage is dropping, you can see the pulse width is increasing and the circuit is trying to maintain 220 volts DC AC at the inverter output. You can see the pulse width is increasing. Let us show the multimeter readings. You can see here the output voltage of the inverter is 218 volts AC. You can see here, and the supply voltage is 12 volts DC. So like this, the PWM function is kicking in. As you can see here, this is the PWM waveform. I am further reducing the voltage. The circuit is still maintaining 208 volts AC and this is the waveform. You can see the waveform has, the time period of the waveform has increased. Now if the voltage increases, you can see the time period will reduce. You can see the PWM is happening. You can see further. You can see this is the maximum possible PWM and the voltage at this point is 247 volts AC. If I further increase, the circuit will shut down. You can see. So like this, the PWM function is working for IC TL494. Let's look into the circuit diagram. As you can see here, this is the circuit diagram. You can see here, this is the pin number 1 and pin number 2. These two pins are responsible for the PWM voltage control. You can see here, this is the reference voltage. You can see from the internal 5 volts DC power supply of the IC. You can see I am using a voltage divider of 4.7K and this voltage is fed to the op amp inside. You can see here, there is a gain of 5. You can see input resistance is 1 kilo ohm and the feedback resistance is 4.7 kilo ohm. So this operational amplifier connected internally has a gain of 5. You can see here 4.7 divided by 1, it has a gain of 5. And here you can see this is a voltage divider network. And this voltage divider network, you can see here, this is the real PWM control. And from here, based on these two input voltages and based on this feedback resistance, TL494 is controlling the output frequency. I am sorry, it's not controlling the frequency, it's controlling the time period. This is how the PWM function is working. You can see here, and here you can see this is the most important thing. The collectors are pulled, pin number 11 and pin number 8. These are the collector pins, and these are pulled up to the supply voltage with a 330 ohms resistance, and the output signal is taken from the emitter. You can see. So from here you can see this is finally connected to the IGBTs 25N120, 25N120. Both the IGBTs are same IGBTs, 25N120. You can see, and you can see here this is the secondary winding of the transformer. This is 220 volts, and this is a bifilar winding of 12 volts each. You can see, and the circuit supply voltage has to be 24 volts. This is an important part. You can see while designing the transformer, if it is a center tap transformer, the supply voltage has to be 24 volts and each winding should take 12 volts each. You can see. So this is how the wiring should be done. So this is the circuit diagram, and here you can see the circuit is maintaining 220 volts AC. It is little high because there is no load. So 220 volts AC, and the supply voltage is now 16 volts DC. You can see this is the raw layout of my inverter, and here you can see this is my small transformer handling the entire power, total power. So this is how the circuit works. Thanks a lot. Thanks for watching. Please watch the description link for the detailed design procedures. Thank you so much.